All right. Okay. No saying dirty words while I do this. All right. If y'all say bad words while I'm doing this, I'll just tell people I'm teaching Baltimore or something. So that's about school. We all just got out of prison. All right. So. No, that's not what I want to do. Y'all don't want this yet. Y'all definitely don't want this yet. You can get it back. You don't have to raise your hand. I'll give it to you. That's not what you want. Okay? That would make you cry right now.
Should we restart the video?
No, you're fine. I can edit that later. All right. Let's see. Here's what I want. All right. So this says more on hypothesis test. So it's basically most of the stuff I've already mentioned. It's just a couple of other little things that are really easy to add on, and this chapter is just supposed to think about what's going on. Hypothesis test more. So we just keep kind of doing the same stuff, and that's why I'm fine with giving you a second shot at this quiz on Thursday. You definitely want to be here on Thursday because the way I'm doing it for you is going to make it nice. You have to take it like Thursday. All right. So, what we're looking at here is more on hypothesis test, and we're looking for just to get some ideas down about what's going on with hypothesis test. So, the test mechanics, first thing this says on here is it just reminds you that when you do a one-tailed test, you really do need to learn this little thing. For a one-tailed test, finding the critical z-value is a piece of cake. Okay? Because you're not always going to have that. You're not going to have that on the AP test. Okay? So find the critical z-value, or they'll give you a value that's different than that. Okay? For one-tailed, it's really easy. Okay? It's your inverse normal times your confidence level. But make sure you write it as a decimal. If you write it as a percent, it's just going to give you an error. Okay? For two-tailed, remember it's a little harder. Inverse normal. 1 minus the confidence level. 1 plus the confidence level over 2. Okay? That's where those come from. That's how we got all of those. That's how you get it. Because remember here, when it's two-tailed, you have to split it up between the two ends. So to split it up between the two ends, we do 1 plus confidence level divided by 2. All right. All right, then you see a few more little hints. Remember, if our p hat is outside our confidence interval, that's when we reject H0. So a second way, and we really haven't done this much, but another way you could do the mechanics of your test is you could actually construct a confidence interval using P0 as the center, and just construct a confidence interval. So you're going to have some value P hat that's like, let's say it's 0.417. And if you construct a confidence interval, which is going to be like P0, okay. And you're probably going, why is he doing P0? Because remember, when you do a hypothesis test, instead of using the P hats in these formulas, we use P0, because we're assuming P0 is right. Okay. One thing you could do is actually calculate that confidence interval. You're not going to have to do that, but you could. And you need to know, if you do that, let's say you got a confidence interval is this. If you calculate a confidence interval and your p hat is outside of that, that's really unlikely to have occurred, okay? So that means we have significant results. So if your p hat is outside of your confidence interval, you can use that to reject a null hypothesis. That could be asked on a multiple choice question. Okay, they'll give you a confidence interval, they'll give you p hat, and they'll ask, how do you know? Or they might ask something like, did you reject it? Did you fail to reject it? How did you know? Okay, you can reject the null hypothesis because p hat's outside of the confidence interval. Okay, so the two ways that I really talked about a lot is if z is greater than z star, or really, I guess we really should say the absolute values, but we'll just stick with this. Okay. If z is greater than z star, or further away from 0, then we also have significant results. Okay. So. Okay, and again, do not worry about absolute values. When you're doing that on a test, you're just going to write z is greater than z star. Somebody asked me last year, what if it's right on the button? Okay, if it's exactly, you can go ahead and reject. Okay, or you can not reject. Nobody will care either way. Okay, most people would rather reject because they're usually trying to prove something. So if you wanted to put or equal to, that's fine. But that's one more little mark. But it's never going to be exactly. It's just not going to. And then finally, the way we've been doing it, if p is less than alpha. So the three things that you're going to use to reject null hypothesis. If your p hat's not inside a confidence interval, that you construct it with the population values, that means our stuff is so rare, this value is so rare that we know we can reject. If z is greater than z star, same thing. The value of z is so rare, we know we can reject. P is less than alpha. We're saying the probability of this happening is so rare, we can reject our null hypothesis. Okay, so I think there's one problem on your next quiz where they give you certain different students did different things, and they say which of the following students can't reject their null hypothesis. And one of them used this method, one of them used this method, one of them used this method, and then the other two just made up weird stuff or something. So watch out for that. All right, again, part D here is just reminding you that alpha is 1 minus the confidence level. And our common way we're going to do this is we're going to reject H0 if P is less than alpha. Remember, rejecting means something significant happened, and that's when we're confident. So we'll say we're 80%, 90%, 95% confident. Okay, otherwise we're not confident. Okay, and finally, one more thing. The logic behind the hypothesis test is this. Okay, we're looking to see if that result we got in our sample is so unusual that we think that's enough proof to throw out the big assumption we started with. Okay, which is whatever the government said the percentage is, or whatever your kicks were last year, whatever our assumption was, we're trying to show our new sample is so surprising that we're going to throw that out. All right, and it's also a little something about ethics on this. Okay, this will matter when you do your project. Before you start collecting your data or whatever, you should always decide on your significance level first. Why? Why do you think that's a rule? What's that?
The rest of your test is based off your confidence interval.
Yeah, but you could go back. Let's say you did the whole thing at 95% and you didn't get significant results. But let's say you're a researcher and you really like, hey, my funding's based on finding some significant results. So you say, but I got a p-value that's 0.08. That won't reject at 0.05. P is higher than alpha. What if I switch to 0.10 though? Now I can say significant. That is like considered really, really, really unethical. Okay, a second thing people do that's considered really unethical. Again, what's a p-value of 0.05? It's saying this is so unlikely it would only happen 5% of the time off a chance. If you turn 5% into a fraction, that's 1 out of 20. Okay? Some researchers used to do something that's called p-mining, which doesn't sound like a good job. Okay? But p-mining is this. Okay? It's when you get a whole bunch of data and you've got over 20, maybe 80, maybe 90 different things, and you're going to calculate p-values for all these different variables. So like you interview people and you ask them 90 questions. Okay? Or let's just say you ask 100. That's an easy round number. If you ask 100 questions of people about different things, okay, do you think that sometimes you're just off of luck, you're going to get in that 0.05 range? Well, yeah, because it's 5%. So if I ask 100 questions, if I do 100 hypothesis tests, even if my hypothesis, my null hypothesis is true, just off of luck, 1 out of 20 times, it's going to look like there's something significant going on. So I actually I ask 100 questions, 5 times I get something that's significant, and I publish it and say it's significant. No, that's called p-mining, and that's like, we were expecting that. There's like a little cartoon I saw about it one time, and they said, they did a test. Red M&Ms cause cancer, no. Blue M&Ms cause cancer, no. Pink M&Ms cause cancer, no. They all kept getting p-values like that were higher than 0.05. And finally, like, purple M&Ms cause cancer, 0.48. And so they got like 800 different colors don't cause cancer. And then they found it for purple M&Ms, and then it shows the headlines in the paper the next day. Scientists say purple M&Ms cause cancer. No, that's just going to happen. If you do that many hypothesis tests, you're going to get some false positives. Okay, so be careful about that. Part 2 is just reminding you, when we're doing these proportions, there's 3 P's. Okay, and next chapter there's going to be 4. Oh, holy cow. Okay, P0, that's the population parameter. P hat is the sample statistic. And the p-value, which our calculator just says p, is the proportion, not the proportion, the probability. The probability that we would have got a result that unusual off of luck. That unusual or more unusual off of luck. Okay. All right, now the new stuff is on the next page. All right, there are 2 types of errors you can make when you do this. There's type 1, there's type 2. Okay, just like diabetes, there's also 2 types of hypothesis test errors. All right, so type 1. Okay, this is this is when we reject the null hypothesis. Okay, that's a type 1 error. It can only be made when we reject the null hypothesis. Okay, so a lot of times I like to ask the question after you do a test, what type of error was made? If you reject the null hypothesis, the type you could have made was a type 1 error. Okay, type 2 error is when we fail to reject the null hypothesis, but it was false. Really easy at the end of a test to know which one you could have made. You say, well, I'm not going to remember. Yes, you are. We either reject, type 1, or we fail to reject. I know it's not the word TWO, but it sounds the same. We either reject or we fail to reject. I just remember if I say fail to reject, the only type of error I could have made was type 2. Is that easy enough? Okay, if you see that word 2, hey, I failed to reject, you might have made type 2. If you reject it, you might have made type 1. Are you going to know if you made an error? No. You're not going to know. Okay, so this isn't like something, oh, now let me go check. Okay, you're not going to know. The only way you would find out if you made an error is to do a bunch of repeated tests over and over again. Eventually, you get so much evidence that, hey, I was wrong. Okay, generally, this is considered more serious, generally. Not always, but generally. Mainly because it's harder to find. It takes more testing to realize you've made this error. Okay, and this one is generally considered less serious. Let's talk about a court of law. Okay, so in a court of law, your null hypothesis is the defendant is innocent until proven guilty. Type 1, this is what we've done in a court of law. We found this guy guilty of murder and he didn't do it. We give him the electric chair. In our system of law, we consider convicting somebody who's innocent way, way, way more horrible than letting somebody go who's guilty, right? You would never want to be the person who like sent somebody an electric chair and they didn't do it. If you found out you did that, you're on a jury and you did that, I don't know if you'd be able to live with yourself, okay? If I let somebody go, didn't do it, okay, well, they'll probably get caught for something else later on, I guess, I don't know. But we generally think that's less serious. So this is, and let's think of something that's more statistical though. What if I test a drug and I say it cures cancer, and then I had made a type 1 error. Well, I ended up saying that drug really works. I made a type 1 error, which means I thought it really worked, but it didn't. I spent millions and millions of dollars making a drug, putting out a drug, giving it to people, doctors prescribe it, and it's not helping anybody. Okay, that's a pretty serious mistake. Okay, here, the drug company, well, it worked. We didn't know it worked, so we didn't give the people the drug. Okay, but we can probably find another one. Okay, but in this case, we're like giving people false hope, killing them. Here, if we just keep testing, we'll see. Okay, we keep testing more, we'll see. Here, we already went to market with the drug. So they like to ask you on AP test, what's the consequence of making a type 1 error? So you say, oh, I've decided it's true, it's not true, figure out how that works in the real world. So you see I have a bunch of reasons down here. And we're gonna talk real quickly about alpha and another thing, beta. So alpha, I just kind of gave you that as a significance, okay? Here's the definition of alpha, which we call significance level. It's actually the probability we make a type 1 error I think that's a little more confusing. Say if, well, let's do that. If the hypothesis is not true, that's right. The null hypothesis. That's better. The null hypothesis is not true. Okay. Now, it's got a buddy. Okay, and 1 minus alpha is called the confidence level. Which is just like 95% or whatever. It's got a buddy, beta. Okay, beta doesn't really have a name like significance. It's just the probability we make a type 2 error. H0 is true. Okay. And 1 minus beta has a name. That's called the power of the test. Okay. So we either have confidence in our test, we have power of the test. Here's the deal. Anytime we do something to make the confidence level bigger, we lower the power of the test. Anytime we do something to make the power bigger, we lower the confidence in the test. Okay? The only way we can make both of these better, the power and the confidence, is to increase our sample size. That's the only way you can increase both power and confidence, is to increase the sample size. All right. I'm going to talk about how all these fit together tomorrow, and I've got a little handout for you as you go. It shows how they fit together. Actually, that's what we want. I'll do that one for the body. I'm just going to do this little.
Oh, it's yours? It's mine?
Yeah.
You can keep it. I don't use wood. I use pens usually.
Do you need the test back, Mr. Gill?
No, I do not need to test back.
He needs mine back.
I'm just going to give you this, and I just want you. No, I'm not going to give you anything. No homework. How about that?
Yes.
Okay.
I messed up on
Tomorrow night you'll
Do you want me to stop the recording?
Do you want me to pause it?
You can stop that now. You just push the little red button.